So now let us see the another concept, that is our relative motion, right? So first of all, let us study relative motion in 1D, right? Say we have a particle A, and this particle is going in the right direction with a speed of 10 meter per second. And there is a particle B, which is going in the right direction with a speed of 5 meter per second. Okay. And the distance between them is 100 meter. Okay.
Yes.
So if we want to find what is the velocity of B, or what is the velocity of B with respect to A, right? Velocity of B with respect to A. So we can write it like this. This is known as velocity of B with respect to A. Now we are observing B with respect to A. So your B will, so your A will be at rest, right? So your velocity of B with respect to A will be written as mathematically as VB minus VA, right? And what is VB? So let us, whenever we have velocities and we are talking about one dimension, always take one dimension direction as positive, another as negative, right? So your VA will be plus 10, VB will be plus 5, right? Both are in the same direction. So your velocity of B with respect to A will be 5 minus 10, right? Which is minus 5 meter per second. Now, the velocity of B with respect to A comes out to be negative. It tells you that with respect to A, B is coming towards A, right? So now the situation becomes like this. This is your A, which is now at rest. And B is coming in the left direction with a speed of 5 meter per second. Is it clear? Okay, let me give you a next scenario. Suppose there are two cars. This is car A and this is car B, right? It is going with say 10 speed. It is also going with 10 speed. So with respect to this A, this car is at rest, right? Because the distance between them is not changing. Okay, so whenever you are observing a motion with respect to an observer, then you have to treat that observer at rest. Clear?
Okay.
So we have treated, now this observer A has comes to rest. And what should be the velocity of B? If the observer A is at rest, it will be 5, right? And this is the mathematical relation. VB, velocity of B with respect to A will be VB minus VA, right? So if I ask you after how much time the two bodies will collide, so that will be distance divided by speed, right? Relative speed. So it will be 100 divided by 5, right?
Yeah.
So the time will be your 100 divided by 5. So it comes out to be 20 seconds, right? So let us see another case. It is moving, A is moving with a speed of 10 meter per second in the right direction, and B is coming in the left direction with a speed of 5 meter per second, right? Now, what is velocity of A? It will be plus 10, right? In the ground frame. Velocity of B will be minus 5, right? So velocity of B with respect to A will be VB minus VA, right? VB is minus 5 minus 10, so it comes out to be minus 15, right? So A will find B is coming towards him with a speed of 15, right? Because both are, they have a speed in the opposite direction, velocity in the opposite direction. Okay. So now if the distance between them is 10 is 100 meter, so time taken, time when they will collide will be distance upon relative speed, which is 15, right? 20 by 3 seconds. So always remember, when two bodies are traveling in the same direction, their relative speed will be difference. You have to take the difference. When they are moving in the opposite direction, you have to sum the speeds, right? Similarly, we can find what is relative acceleration, right? Relative acceleration will be AB minus AA, right? Suppose now we have a case, this is A, which is moving with a speed, say 10 meter per second. And there is another object B, which is moving with a speed of 10 meter per second, right? And it has an acceleration of 2 meter per second square. It has an acceleration of 1 meter per second square in the right direction. Okay. And the distance between them, let us say, is 100 meter. Okay. Now we have to find after how much time they will collide, right? Find time taken when they collide, right? Is it clear? So first of all, let us study this problem with respect to, say, you can study with A or with B, right? You will get the same answer. So let us study, solve this problem with respect to B, right?
Hmm.
So with respect to B, so velocity of A with respect to B, right? So now velocity of A is plus 10, velocity of B is plus 10, initial velocity, right? And acceleration of A is 2 and acceleration of B is 1, right? Now, initial velocity of A with respect to B will be UA minus UB, right?
Yes.
UA is 10, UB is 10, right? So it comes out to be 0. Acceleration of A with respect to B, it will be acceleration of A minus acceleration of B. Acceleration of A is 2 minus 1, that comes out to be 1, right?
Hmm.
Now, with respect to B, now this since A has more acceleration, right? You can see the acceleration of A is 1 in the right direction. So eventually A will collide with B, right? Okay. So what? So the distance is 100. So we have to find the time, right? So you can apply displacement of A with respect to B will be U of A with respect to B into T plus half acceleration of A with respect to B into T square. Okay, so we can apply equation of motion if the acceleration is constant. If the relative acceleration is constant, then we can apply equation of motion. Clear? So what is the displacement? Now the situation is this. Let me redraw the situation. It is at rest, right? B is at rest, and A has an acceleration of 1 meter per second square. And initial velocity is 0, right? Is it clear? Now it is accelerating, and this distance is 100. So displacement of A with respect to B will be 100. Initial velocity is 0, half. Acceleration is 1. So that will be the time, right? Time will be square root of 200. Is it clear? 10 root 2 seconds. Okay. So that is the answer. So relative motion we will utilize in finding the distance of the closest approach. For example, two bodies are moving, right? Say, let me give you an example. Suppose a body is moving in this curve, another is moving in this curve, right?
Hmm.
Say, so the distance is right now is this. Suppose A is here and then B is here. So the distance is this, right?
Hmm.
So we have to find what is the distance of closest when the distance is closest, right? Smallest distance between them. So such kind of a question. And then there are river problems, and then we have wind plane problems, and then rain problems, right? So let us first understand this distance of closest approach with an example, right? So find the distance of closest approach and the time when they are closest. So we have two particles A and B, right? A is moving towards west and B is moving towards north, right? And the distance between them, initial distance is 10 meter, right?
Hmm.
Now we have to find what is the distance of closest approach. So, right, smallest distance between them. Right now it is 10, right? So what we can do, you can study the motion of A with respect to B, and your B will be at rest, right?
Hmm.
Okay. And we know that if a particle is moving in a line, and this is the point, right? What should be the minimum distance? A particle is moving on this line, right? So when the particle is right at this particular location, this distance will be minimum, right?
Hmm.
Okay. So let us study this problem with respect to B, right? So with respect to B, velocity of A with respect to B will be velocity of A minus velocity of B, right?
Hmm.
So we can also write this as velocity of A plus minus of velocity of B. Okay. So it will be like this. So we have VA in this direction, right?
Hmm.
And minus VB in this direction.
Hmm.
And the resultant of these two will be this. VA is constant, VB is constant, so VAB must be constant, right?
Hmm.
So let me draw this. So this is your minus VB, right?
B.
And this is your VA, right? So the resultant, it will go in this direction, right?
Hmm.
So that is the line of motion of A with respect to B. Is it clear? And it has a constant magnitude, right? So the velocity is constant, so it is moving uniformly.
Hmm.
So, and this is a point which is at rest. Now it is at rest, right? Okay. So we have a
Hmm.
line and there is a point. So what is the minimum distance between a line and a point? If you drop a perpendicular, right?
Hmm.
So this is the point, right? When your A is at this particular location, at that instant, the distance between A and B will be minimum, right?
Okay.
Clear?
Yes.
So now, what is this angle? What is this angle? Both have the same magnitude, so it will be 45 degree, right?
45. Hmm.
So this is 45. So we can say this is 10, right?
Hmm.
So this will be uh, 10 by root 2, right? So the distance of closest approach is 10 by root 2. And what should be the time when they are closest to one another? What should be the time? So time will be from A to A dash, right?
Hmm.
Time taken by A to move from A to A dash, right? And what is the speed of A? That will be the resultant of this relative velocity, right? What is the magnitude of VAB? It will be root 2 times 10, right? It has a magnitude 10. It has a magnitude 10. Now two vectors are at right angle, right? So their resultant will be 10 root 2, right?
Yes. Yes.
So that is the speed, right? Speed with which A is moving along a straight line.
Hmm.
So what is this distance? So what is this distance we know, right? This is again 10 by root 2. So time will be distance upon speed, right? So it comes out to be 10 by root 2 into 1 upon 10 root 2. So it comes out to be 1 by 2, right? So 0.5 second. Clear?